So now we'll continue with the next method. So we'll do the isEmpty method. Actually, we'll do some Javadoc first, so we'll just say returns true if this queue is empty and false otherwise. And we'll say return true if this queue is empty. And we'll say public boolean is empty. We've seen this one before, of course, so returns true if count is less than or equal to 0. So here we'll do size. We'll do some Javadoc returns true if this queue. Actually, sorry, no, that's wrong. So returns the number of elements currently in this queue. And we'll say return the size of the queue. So here we're just going to do public int size. Return count. And here we'll just do a toString. We'll just say returns a string representation of this queue. We'll say return the string representation of the queue. Then public string toString. String result points to an empty quote, or just equals an empty quote. And then we'll say int index points to front. Then here we'll say for int I equals to 0, I is less than count I plus plus. Result plus equals, so result equals to result plus q of array index. We'll say index equals to index plus 1 modulus q.length. Then we'll just return result. What's wrong with that? Okay. So we'll just say actually, sorry, so we'll just review this. So we have our variable empty string quotes. So it's just a variable set to empty quotes, and then we'll set index pointing to front. For int I equals to 0, I is less than 5, or we'll just say count. Count gets incremented every time we add something. So let's just say we have 3 elements in there. So 0, 1, 2 indexes are full. So we'll say int index points to the front. So front is 0. So for int I equals to 0, I is less than count, I plus plus. Result equals to result plus q of index. index points to index plus 1. Index points to index. So index is 0 because we have index points to front, which is 0. So result points to result, or result equals to result plus q of index 0. And then we'll say index equals to index plus 1, so 0 equals, so index equals to 0 plus 1, which is 1, modulus q dot length, which is 5 in this case, then return result. So it's going to go, so if we have 3 elements in the queue, then it's going to go index 0 to 2 and print it out. That's all it's doing. You can do this in different ways. You don't have to do it this way. You could have just used a normal array printout, and you could have just printed null if it was null, or you could have just went to count and just printed it out. That's just one way to do it. So that's all good. We finished that one pretty quick. That's it. I think that's it. We have toString size is empty. First, you can do a rear. Actually, we don't need to do a rear. We will in the doubly linked queue. We're going to do that one next. It's going to be, you can remove from either sides, and I think you can also remove from the middle. And you can add to the front and the rear. Then we'll be done with this, and we'll be doing the lists. We have a few lists to do. So then, yeah, so stay tuned for that. We'll just debug this. We'll just do an example just to see how the processing is working. So we have on queue, expand capacity, DQ first is empty size. So we think we got everything. It's a little big. So we will go into main. Just check for errors here. Don't think we have any errors. It's all good. So we'll just go to main, and then we'll delete this. Sorry, I'll delete that. If you have that, you can delete it too. Just create a main class with a main method, and then we'll just create a circular array queue. We'll instantiate an object here. So just write actually I'll write it out. So circular array queue. We'll name it. Actually, we need a type, so we'll just store integers in there. We'll just call it, it's kind of a long name, so we'll just write queue points to new circular array queue of generic type, actually not generic type, so integer. Are we doing a size? No. We can. So if we're not doing a size, we're just going to use a default capacity. So yeah, we'll just leave it like that, and we'll do the overloaded method call, or constructor call, and we'll say q dot in q5, q dot in q6, q dot in q11. We'll just start with that. We'll add 2 more, and then we'll remove some. So we'll set a breakpoint here, and then we'll start debugging. Just click the debugger at the top right corner. So this should be out here, I believe. First, yeah, that should be out there. Just move these brackets up. Save and re-debug that. Might have that somewhere else as well. Okay, this is using Java 15 to compile. I thought I set it to 11. Usually I just use JDK 11.02 or something. So here we have our circular array queue. We'll step into that. Then we have our instance data here. Default capacity, front, rear, and count are all 0. Queue is null, so the only thing really it should say is, okay, it doesn't show our constants for some reason. So it says object is being initialized. This, so it's going to call this constructor and then pass in default capacity. So initial capacity is going to be default capacity, or initial capacity, sorry, is going to be the default capacity, which is 5. That's what it's really saying. So it's saying, okay, go to this constructor, the only other one, and take default capacity and pass it in as initial capacity, because this one takes an int. Default capacity is an int. So it's just going to use the same type and pass it in as initial capacity. So initial capacity is default capacity, which is 5. Then it's going to set front to point to rear, to point to count, to point to 0, so they're all going to point to 0. Then it's going to instantiate our new queue with initial capacity as the instantiated array. That's done, and you can see we have our memory location given for our queue object. And then that's at memory location 950. So that's all good. And we'll go to the next line. So you can see our instance data here. Front is at index 0. Front is set to 0. Rear set to 0. Count is set to 0. For some reason it's not showing us our default capacity. That's strange, but that's okay, we know what it is. Maybe it's because a constant doesn't show it. That's kind of weird. It should show it. Wonder why it's not showing it. I guess it just has our size there. It's 5. You can see object array of size 5 at memory location 950 beside Q right there. So anyways, we'll step into our q.inQ method. So again, we're passing in the element 5 to the parameter. So we're saying if size is equal to q.length expand capacity, that should be skipped because size returns count. Excuse me, so count is 0. So if size is equal to q.length expand capacity, so size is not equal to q.length, so it's going to skip because q.length is 5 at this point. You can see it there. It's still weird that it doesn't show our default capacity. That's okay. So that should skip right to here. And then it did, so q of index rear, which is 0, points to the element. So now the our q array of index 0 is going to be pointing to the element 5. So q, can we see Q here, so all elements are null, so there we go. Step into, then click on Q, and we'll see index 0 is now set to 5. It has its memory location now. This has its own memory location. Then rear now points to rear plus 1, so rear points to rear, which is 0 plus 1, so 1 modulus q.length. Q.length is 5, so 1 modulus 5, so rear should just be 1. Rear is 1. Then it'll say count, then it's gonna execute count plus plus, so count should go from 0 to 1. It did, so now count's 1, and we're done. We'll go to the next one. If size is equal to q.length, well, count's 1 now, so we'll go into the method, so step into it. Return count, so count is equal to 1. So if count is equal to q.length, which is 5, is 1 equal to 5? It's not, so it's going to skip. I don't know why that brackets are like that again, but that's fine. So q of index rear is 1. So q of index rear is going to be nq to the rear, remember? So it's going to be like, if there's an element here, then it's going to go to the next one, just where the mouse is. If there's an element like here, we have 5, and then now we're going to, this is the front, right? Before the 5 is the front, and this is the rear behind the 5, so we're going to put 6 behind 5. And then when we dequeue, it's going to dequeue from the front and take 5 away. But right now we're just storing it in the queue. Remember, it's like a waiting line. We're in a waiting line, we're at a traffic light waiting for our turn. So here, q of index rear, which is q of index 1, is now going to point to 6, so we'll see our q change here. So now q of index 1 points to 6. Then rear points to rear plus 1. So rear, which is, well, so rear points to rear, which is 1, plus 1, so now rear is 2. 2 modulus q.length, which is 5. Q.length is 5, so it's just going to be, rear should just be equal to 2. So there you go, rear is now 2. Count plus plus, so 1 plus 1, that equals 2. Count just changed to 2, and we're done. Same thing here. If size, which is now, what is size? Should be 2. If does 2 equal to 5? It doesn't, so skip. Q of index rear, which is 2, so the third index, which is index 2, the third element, so 0, 0th index, 1 index, 2 index. So now we're at the 2 index, which is empty currently. See, just 0 and 1 are in the queue. So we're going to say q of index rear, which is 2, point to the element. Rear, which is 2, equals to rear, which is 2 plus 1. So rear equals to rear, which is 2 plus 1, so 3 modulus 5 should just be 3. There you go, 3 count plus plus. There you go, so we'll stop that. We'll add, like, why don't we just add 3 more? I'll just copy this, use code reuse, and then we'll just add 13 here. Let's just add like another one, like 15, and then we'll add 10 million is kind of big, so we'll just add 21. So we'll just use those numbers. We'll go back here to 13. We'll start debugging at that point, so set a breakpoint at line 9, or wherever it is you have 13 at. So we'll step into it. If size is equal to q.length, so we'll step into it again. Return count is 3, So if 3 is equal to 5, it's not, so skip. Because currently we have 1, 2, 3, so our count is 3. So is 3 equal to 5? Is that a mistake though? Because 1, 2, actually yeah, that's fine. That's okay. So step in. Step in. We're going to skip. Then we're going to say q of index rear. Q of index rear, so rear is 3. So if q of index 3 points to the element, so right now 0, 1, 2, there's just 0, 1, and 2 elements in the indexes that are full are just 0 to 2, including 2. So the third index, which is rear, is going to be set to the element. There you go, 13. And then now rear is going to shift for the next element. It's kind of like top. It shifts for the element for the next one and it counts. So right now rear is going to become 4. So rear equals to rear, which is the current rear, which is 3. Whoops. Rear points to the current rear, which is 3, plus 1, which is 4. So rear equals to 4 modulus q dot length, which is 5. So 4 mod 5 is 4. So rear is going to change. And then we could see now rear is really just tracking how many elements are in the array and which index the next element is it going to go to. I think that's exactly like what top does in our array stack, and I think, yeah, just array stack. That's what it does. Maybe in our link stack too, I can't remember. But that's okay. So then we'll say count plus plus. So 3 plus 1, that equals 4. So it's gonna, so count is 3 right now. Plus 1 is gonna equal 4. Then we're done. Then we go to the next one. If size is equal to q.length, so we're gonna step in. So count equals to 4. So if 4 is equal to 5, is 4 equal to 5? It's not, that's false. So this if condition is false, it's going to skip. Q of index rear. So Q of index 4 points to the element. So here we have our Q, index 4 is empty. So now we're going to take index 4 and put the element 15 in it. Then rear points to rear plus 1. Rear points to rear, which is 4 plus 1 is 5. 5 modulus 5 is 0, I think, from our thing. Is that correct? So we have, yeah, I think that's correct. 0, 1, 2, 3, 4. So we have 5 things in our queue now. Do we really? Yeah, we just added the last one, okay. Or the second last one. Excuse me. So we added our queue, so we added our element to the queue. We unqueued it to the rear, that's what we just did. Then we'll say rear points to rear plus 1, so rear points to rear, which is 4, plus 1, that's 5, so 5 modulus 5, q.length is 5, so we should get rear equals to 0. Count plus plus. Count. There we go, count is 5, we have 5 elements now, and we've shifted back to the front of the queue. Yeah, that's right, the front of the queue. So, personally, why it goes in a circle is kind of like, I think it's just to make it a little bit more efficient, honestly, because of the second reference to the rear, but we'll just continue with a few more just to see if it is really any better. So we'll step into it. So q dot in q, well in q21. So we will have to expand here, so if size, which is 5, is equal to 5. We'll have to step into expand capacity, so t larger points to, so we're going to instantiate a new array that's going to be of size 10. There you go. Size 10, we can see that 10 in the array brackets. So we'll say for int I is equal to 0, I is less than count. I is equal to 0, I is less than count, which is 5. I plus plus, larger of index, okay, we'll step in. 0 less than 5, I plus plus, so larger of array index 0 points to Q of array index front. So it's going to take front is 0. It's going to copy that first element into larger of array index I. So a 5 should be put into array index 0 of larger. There we go. Then front points to front plus 1. So front points to, so we'll just check what front is again. It should be 0. Just collapse this stuff here, okay, we don't need to. So front, which is 0, points to front, which is 0 plus 1. So front equals 0 plus 1, which is 1, modulus 5. So front equals to 1. There we go. Then, why is that bracket there again? They keep changing it. So it goes from this bracket back up to the for loop. So we're here. It's finished. It loops right back up here. And then I increments by 1 when we get here. So I equals to 1. I is less than 5. I plus plus. Step in. See, I is 1 now. Larger of array index 1, which is null right now. I'll move this up a little bit. So larger of array index 1 points to Q of array index front, which is 1. So it's going to copy, so larger of array index 1 is going to point to Q of array index 1, so it's going to copy 6 and put it into larger of array index 1, so we should see a 6 come up under 5. There we go, 6 come up under 5 right here. It came up under 5, so we copied it. Then now front's going to shift, so front points to front, which is 1 plus 1, which is equal to 2. 2 modulus 5 is equal to 2. So we should see front change. Front is 2. Then we're going to hit the loop again, so it goes down, then goes back up. I increments by 1, so 1 plus 1 is 2. I is going to be 2, so now the condition is I equals to 2, 2 is less than 5. I plus plus. Then we'll say larger of array index 2 points to Q of array index front, which is also 2. So larger of array index 2, which is null right now, is going to point to Q of array index front. Front is 2, so 0, 1, 2. So we're going to see that 11 basically just come up under here. So larger of array index 2 is going to become 11. That's all that's happening. There you see 11 was copied there. Then front is going to shift. So front points to front, which is 2, plus 1, which is 3. 3 modulus. Actually, did Q length change? Yeah, it did change. Wait, no, it didn't. It didn't change. Okay, so front points to front plus 1. So front points to front, which is 2 plus 1, 3, modulus Q dot length, which is 5. So 3 modulus 5 is just going to be 3. So our front should change to 3. It did, so now we're at the end of the bracket. We come back up for the loop, increment I by 1. So I is going to be 3 now. 3 less than 5. So larger of array index 3 points to Q of array index front 0, 1, 2, 3. So larger of array index 3, which is null right now, is going to point to Q of array index front, which is 13. There we go, it copied. It's just copying the elements. And then front points to front plus 1. So front equals to 3 plus 1, which is 4. So 4 modulus 5 is just 4. So front's going to shift by 1. Then we've come down to the loop bracket. We're going to loop back up, increment I by 1. So I increments by 1, so I is equal to 4. 4 is less than 5. So that's still true. So larger of array index 4 points to Q of array index front. So index 4 is null in larger right now, so we're going to say take your null index and point it to, take your index 4, which is null, and point it to Q of array index front, which is 4. So it's going to copy 15 and put it under 13. There you go, it copied it into this array. Then front's going to shift again, so front equals to front, which is 4 plus 1, which is 5, modulus 5 should be 0. Front is 0. End of the loop, loop back up from the bracket to the condition again. I is going to increment by 1, so for I equals to 5. 5 is less than 5. Is 5 less than 5? It's not. So that's false, we're going to skip it. Front is 0, isn't it? Yeah, it is, so we're going to go down. It was already 0, I'm not sure why they're resetting it to 0 again. So front is 0. Rear is set to count. And Q points to larger. Yeah, okay, that's fine. So front is already set to 0. Rear is at 5, it's going to get set back to count, which is 5. Unless it already changed. Okay, I forgot if rear was at 5, but it's okay, it's being set back to 5. And then Q is going to point to larger. Done. So rear is at 5. Q of index rear. So now, I think there's, yeah, so Q is gonna, there's actually 10 elements now, not 5, so we have more room. So Q of index, that's just the way they copied it. They're keeping the same array, it's kind of a little trick, and then we've basically copied the same elements into the old one. And we've now pointed it to somewhere else, so basically we're just expanding the capacity of the array. So instead of 5 elements, we have our Q.length is 10. So it changed from 5 to 10. So Q of array index rear, which is 5. Index 5 points to the element 21. So we should get array index 5 will now equal to 21. Under there. There you go. Then rear points to rear plus 1, so rear points to 5 plus 1, which is 6. Modulus 10. So 6 mod 10 is just 6, and then we'll increment rear, and then count increment by 1. So that's it. That's all it's really doing. And I'll see you guys in the next video. Thanks.